Good morning. Today is April 6th. It's Monday. And we had a Zoom meeting this morning, and I kind of went over how to do this kind of math. However, I forgot that starting today, Zoom was requiring passwords to get into every meeting. I knew that was going to happen, and I forgot. So it's my fault, and I am sorry for those of you who wanted to be in the meeting and missed it. So I'm going to record this lesson for math that we talked about on Zoom today. It's going to be kind of a shortened version of what I taught you on Zoom, but it still works and it's just fine. So today's math is easy, so I wasn't going to give you a lesson on today's math. Today's math is comparing fractions like we have been, either with fraction strips or with pie charts or some other kind of visual so you can look at it and decide which one's bigger, which one's smaller. The next page is a cutout page of fractions on cards. You can cut them out and you can put them from the smallest fraction to the biggest if you want. On your lesson plans on mrsannpape.com, I said that page was optional. This page here with the cutouts, putting them in order, that's optional. If you want to do it or if it gives you more practice, that's a great thing. This is tomorrow's math, and this is the one I'd like to give you some help with. No pictures this time, no pie charts, no fraction strips. We're going to learn to compare fractions without those things. Okay? So I'm going to start with, they give you a little bit of an explanation right here, and that's fine. And I'm just going to kind of go through that explanation and so you can use that if it makes perfect sense to you, or you can use my explanation if it's a little bit easier. When you're comparing fractions, it's hard to compare a fraction when they don't have the same denominator, when they don't have the same bottom number. It's a little bit harder to decide which one's bigger, which one's smaller. For example, 3/12 and 4/8. When we look at those two fractions, unless we draw pictures or get our fraction strips out, it's kind of hard to tell right off the bat when you don't know fractions really great. It's kind of hard to tell right off the bat which one's bigger, which one's smaller, or are they equal? So I'm going to show you a way to decide that. The way to decide that is to get both bottom numbers the same. We want matching denominators. Okay? So we look at those denominators, 12 and 8. What will 12 and 8 both fit into? 12. 8 won't fit into 12. 12, let's do counting by. 12, 24, 36. Let's do 8 counting by. 8, 16, 24. I heard a match, 24. As soon as you hear a match doing counting by, that's going to be your new denominator, okay? Let's try that again. 12, 24, 36. Now let's do 8 counting by. 8, 16, 24. I heard a match, so I'm stopping. Don't keep going. As soon as you hear a match, stop and use that number that you stop on for your new denominator. We came up with 24. So I'm going to make a denominator at the bottom for both fractions that's 24. Now, how do I turn 12 into 24? If I want 12 to become a 24, what do I do to it? To make 12 into 24, I have to times it by 2. Correct? So in timesing 12 times 2, I came up with a new denominator of 24. If you see that you times the denominator by 2, you have to do the exact same thing to the numerator. Whatever you do to the denominator, you have to do to the numerator. It's just fair. Think of if your mom gives your brother 5 cookies and you say, wait, I want 5 cookies too. We have to be fair. Numerator, denominator do the same thing. Because in this fraction I times the denominator by 2, I have to times the numerator by 2 as well. So I'm going to do that. 12 times 2 is 24. What's 3 times 2? 6. So my new fraction for 3/12, the exact same fraction as 6/24. They're the same thing. It's the same amount of pizza. 3/12 pizza is exactly the same as 6/24 pizza. But the reason we're doing this is because we're getting the denominators to be the same so that you can do some comparing, and it's way easier to compare. All right, now let's doing the same thing on the other fraction over here. How do we turn 8 into 24? We multiply it by something. What? 8, 16, 24. So we multiplied 8 by 3. Remember that rule about fair that I told you. Since we times 8 times 3 to get our new denominator of 24, to be fair, you have to do the exact same thing to the numerator. Times it by 3. 8 times 3 is 24. That's what we're seeing down here. Now we need to fill this number in. 4 times 3 is 12. So now look at the first two fractions, 3/12 and 4/8. Those were hard to compare. It was hard to look at those and decide which one was bigger, smaller, or were they the same. But now look at the fractions. 6/24 or 12/24. That's a piece of cake. 6/24 is smaller than 12/24. All right, I'm going to do that again, and then I'm going to write down the steps for you. Next fraction is going to be 1/3 and 1/3 and 2/9. Now I look at those, 1/3 or 2/9. I wonder which one's bigger. It's hard to picture if you don't get to use your fraction strips. It's hard to picture if you don't get to use some kind of pie chart. So, step 1. What number will both of those times into if we're counting by? So let's count by 3s. 3, 6, 9, 12. Let's count by 9s. And as soon as we hear a match, we stop. 9. We're going to stop. And we heard a match already. We didn't even have to count by 9s. So 9 is going to be our new denominator. How did I get 9 to turn into 9? I times it by 1. So do the exact same thing above to the 2. So when you do that, that fraction will stay the same. 9 times 1 is 9. 2 times 1 is 2. So that fraction is going to stay the same. That doesn't seem all that helpful yet, but once we change this one over here, then it'll be very easy to compare the two. 1/3 and 2/9 are hard to compare. But once we get them down here and they both are 9ths, then it's a really easy way to compare. All right, so we already multiplied those out. Let's work on this side over here. How do we turn 3 into 9? We times it by 3. And remember, if you do that to the bottom, you have to do the same thing to the top. So now we have 3 times 3 is 9, and that's what gave us our new denominator. 1 times 3 is 3, and that will give us our new numerator. Now look at those. Aren't those easier to compare? 3/9 and 2/9? 1/3 and 2/9. It was hard to decide. 3/9 and 2/9 is not hard to decide. So let's review. The first step when you have two fractions with different denominators. Step 1, find the number that both denominators will multiply into. Both denominators, that means both bottom numbers, will multiply into. That is step 1. Find a number that both the denominators can multiply into. The second step is use that number as your new denominator. Now you have a new denominator on both sides that matches. Step 2, use that number as your new denominator. Step 3, multiply the numerator and the denominator by the same number. By that same number. Okay, so step 3, multiply the numerator and the denominator by the same number. Those are the directions. Okay, I'm going to say each of those steps as we do one more. 3/8 and 2/6. Okay, step 1 said, find a number that both denominators will multiply into. 6 and 8 won't fit into each other in any way, but they will both multiply into something. They will both multiply. Let's do counting by again. And stop as soon as we hear matches. First, let's count by 8. 8, 16, 24, 32. Let's count by 6s now and stop when we hear a match. 6, 12, 18, 24. I said 24 and 8, and I said 24 and 6. We have a match. We have a match, people. Okay, so now we have a new denominator. Step 1 said, find a number that both denominators will multiply into. So I found 24. That number will be our new denominator. Step 1, find a number that both denominators will multiply into. Did it, 24. Step 2, that number becomes our new denominator. Done. Step 3, multiply both the numerators and denominators by the same numbers. 8 times something is 24. 8 times 3. So I have to multiply both the numerator and the denominator by the same number. Because I have to figure out how 8 gets into 24, I times it by 3. Since I did that, you have to do the exact same thing to your numerator. So 8 times 3 is 24. 3 times 3 is 9. Now I have a new fraction with a 24 for a denominator. Let's do the same thing on the other side. Step 1, find a number they will both times into. Step 2, make that number your new denominator. I did that. Step 3, multiply your denominator and your numerator by the same number. How did I multiply 6 to get 24? I multiplied it by 4. You have to do the same thing to the numerator. Oops. 6 times 24 is 24. 2 times 4 is 8. Now, I had 3 eighths and 2 sixths. That was hard to compare. But once I've changed the denominators and now I have new fractions, I've got 9 24ths and 8 24ths, and those are very easy to compare. I hope that helps a little bit, but if it doesn't, it's really hard to show you things on the whiteboard and not get to practice with you individually and do some over and over. If it doesn't help, let me know and we can Zoom, just you and me, or 2 or 3 kids and me, whatever works. But I want to make sure that you understand this. Changing the bottom denominator to make fractions easier to compare. I hope I haven't confused you even more than you were when we started. Hopefully that was helpful. If not, please let me know.